Hello and welcome everyone. I am Avinash Sahu and today we study about the chapter Work, Energy and Power. This chapter play a very important role to understand the physics, so it is very important chapter, and in this chapter we study about the terms, concept of work, types of work, and after that we will study about the terms and different energy and its different forms, and finally we understand the terms power. So one by one we study about it. Firstly we discuss about the term work, and before going to start work we use some mathematical tools which is very important to understand the work. So let's start with these mathematical tools. So one of the important tool is that cos theta is the value of cos theta. We know that the value of cos theta is cos 0 degree is 1, value of cos 90 degree is 0, and value of 180 degree is minus 1. We know that, and if you don't understand the terms, if you don't know the term about cos, so it is very important that you understand these terms. Suppose that there is a right angle triangle and this is a angle theta and this is 90 degree angle. A side of triangle which is opposite to the right angle, it means 90 degree angle, this is known as hypotenuse, and the angle and the side which makes angle and 90 degree is known as base, and the opposite of the angle, opposite of this angle, the side which is opposite to the angle which is known as perpendicular. So what is cos theta? Cos theta simply a ratio of base and hypotenuse. So what is the meaning of cos theta? Cos theta means the ratio of base upon height. This ratio is known as cos theta. Okay, so and another term, so and the value of the cos theta is a kind of angle. Okay, it is an angle. Okay, what is theta? Theta is a angle. So the value of, we remember these terms, the value of, we will remember these terms, cos 0 degree is 1, cos 90 degree is 0, and finally cos 180 degree is minus 1. Okay, so after this mathematical tools, okay, it is very important we know about the term scalar and vector. Okay, scalar and vector, physical quantity, any physical quantity. Okay, physical quantity. What is the meaning of physical quantity? Physical quantity means those quantity which can be measurable. Okay, suppose that time, temperature, length, speed, distance, we can measure it, so these are physical quantity. Okay, there are a physical quantity may be scalar or vector, maybe scalar or vector. Scalar quantity are those quantity which has only magnitude, it does not depends upon direction, For example, time is a scalar quantity because it has only magnitude, 2 hours, 3 hours, 1 minute, 2 seconds. It does not depends upon directions. Okay, and second thing is vector quantity. Okay, second thing is vector quantity. A vector quantity are those quantity which has magnitude. Magnitude means numerical value. Okay, it has some numerical value, as well as it also depends on direction. You can say that it has direction also. And example of this is displacement. Okay, displacement. Displacement means shortest path covered by the body is known as displacement, and it has a direction initial to final. Okay, well, let us understand more it with the example of distance and displacement. If I am saying that a person cover 5-meter distance, then suppose the direction is in this direction, this is north, this is east, this direction north, this is west, and this is south. Now if I am saying that a person covered or traveled 5-meter, then what it means? It means it may be travel 5-meter in east direction, it also may be 5-meter in north direction, it also may be cover 5-meter in west directions, or maybe it is in south. But if I am saying it means it may have any directions, because it does not depends upon directions, distance does not depends upon directions, so it may be possible. Okay, but if I am saying that a person is moving 5-meter direction to 5-meter, okay, 5 cover 5-meter in north direction, then it definitely it covers 5-meter in this way, 5-meter in this way. If I am drawing, if we draw the, if we show this, then this is wrong. Okay, because if I am saying that a person cover 5-meter in north direction, then it has 5 meters magnitude and it has a definite directions. So let us understand the term work with this example. Suppose that there is a wall in front of you, and in front of you, and you trying to push it. Okay, at the morning you start to push it, and whole day you push it, but wall is not displaced. Okay, but wall is not displaced, displacement of the wall is 0, and you pushed it a lot. At the end of the day you came and saying that, sir, today I did lots of work. Then I am saying that no, you did nothing. Then you get surprised, sir, how? I spent whole day to pushing the wall, and doing this I spent lots of energy. Okay, then I am saying again, this is you did nothing. Then you saying that, sir, how? Then I am saying that actually work depends upon 3 factors. Number 1 is force, number 2 is displacement, and number 3 is the angle between force and displacement. Firstly, we give the symbol of the force is F, symbol of displacement is S, and finally the symbol of angle is theta. Okay, so what is the exact definition of work? Okay, work is said to be done when a force is applied on a body and body displaced in the direction of force applied, then work is said to be done. So write down the definition of work. So write down the definition of work. Work is said to be done when a force is applied on a body and body displaced in the direction of force applied, in the direction of force applied. So work is said to be done when a force is applied on a body. Force is applied on a body and body displays, body show displacement in the direction of force applied, in the direction of force applied. So in a short way you can say that work is the product of force component. If I'm about the work is defined as the product of force component in the direction of displacement of the body. Force component in the direction of displacement of the body, then work is said to be done. Okay, so what's the definition of work? Work is said to be done when a force is applied on a body in the direction of displacement and body displaced in the direction of force applied. It means say that you can say that this is the definition, you can write the definition. Okay, now there are three things, as I told you earlier, that force depends upon three factors. Number one is work is depends upon three factors. Number one is force, second one is displacement, and third one is direction. Okay, direction means angle. Okay, here direction means angle. Now we trying to understand these terms. Okay, now we trying to understand these terms. Let's start. Suppose that there is a body, okay, suppose that there is a body, here body is A, okay, and you applied a force in this direction. Okay, then body moves and reached at position B, okay, by traveling some displacement S. Okay, so what happened? It moves from the point A to B by applying a force F. Okay, so the definition of work is, it is the product of force component in the direction of displacement, so what's the how much amount of force we applied in the direction of displacement? We applied F amount in the direction of displacement. So it is the product of force component and displacement and body displaced up to S. So this is the formula of force when you applied a force in the direction of force applied, when you applied a force in the direction of displacement. But what happened? Actually this is a incomplete formula. Okay, this is incomplete formula. If you complete it, then you trying to understand this example. Okay, try to understand this example. With the help of this example, you can derive the exact definition of the exact formula of the work. Suppose you have a toy. Okay, you have a toy car, and what you did, you tie it with a string, okay, and start to applying force F by your hand. Okay, by your hand. Then what happened? Car is moving along your strength? No, this toy is not moves along the direction of force. It moves along in this direction. Okay, it moves along in this direction. Okay, the toy is moving, this car is moving along this direction. Then what happened? Actually, when you applied a force in this direction, there is a force component. Actually this force is a vector quantity. This force is a vector quantity, and you can resolve this vector quantity in two component. Okay, in two component. One of the component is F, if you're saying about the force, F cos theta, and second component is F sin theta. Okay, there are two component, a vector quantity has two component, F cos theta and F sin theta. Okay, the angle between, let us consider the angle between force and displacement is theta. So what happened when you talking about the component F cos theta or F sin theta, then this has a component along the displacement which is F cos theta. You remember this point. Okay, this is the force component, this is force component along displacement, which is force component which is F cos theta. It means if you taking the force F, then this value has F cos theta. That's the magnitude of this force along displacement is F cos theta. Okay, along displacement is F cos theta. Remember, you have to remember these points. Okay, firstly, force is a vector quantity. A vector quantity has two components, F cos theta and F sin theta. F cos theta is along the displacement and F sin theta is perpendicular to the displacement. We not discuss about the F sin theta. Okay, we just talking about the F cos theta which is along the, so component along S is F cos theta. So this is very important component. We most of the time we are not saying that all the force is not acting. Always force is not acting at 90 or at 0 degree. Okay, it may be at you applied a force in this and body displaced at this at angle of theta. Then what you did, then you take the F cos theta component, F cos theta. Okay, F cos theta along the S displacement. So in this way the exact formula becomes of the exact formula is F cos theta. Okay, this is force and S, this is displacement. Okay, this is displacement, this is force component, it is and displacement. So the definition of the word, there are two many ways you can explain the define the terms work, but one of them is as write on the board, which is it is when a force work is said to be done, a force is acting on a body and body displaced in the direction of force applied, then it is said to be work is said to be done. Okay, in this case you applied a force and body displaced in the direction of, then formula becomes this. And when you're talking about the general discussions, then what happens, you applied a force F at an angle of theta with displacement, then what happens, then force becomes, it is a product of force component. You can also define the work as it is a force component, it is a product of force component and the displacement. Okay, and the direction of the displacement is along the force applied. Okay, and the direction is along the force applied. So in this way you explain the terms and write down the formula. This is very important formula which is generally write at, you can, when you solve this formula, then you can write it Fs cos theta. So this is the our main formula of the work, main formula. Okay, and you have to remember the value of F 0 degree, cos 0 degree, cos 90 degree and cos 180 degree. You remember this value. Okay, cos, if cos is 0 degree, then its value is 1, cos 90, then its value is 0, and cos 180 degree value is minus 1. You remember this value, okay, cos 0 degree, cos 90 degree, and cos 180 degree. Okay, so in this way you can explain the term work. Okay, work is equal to Fs cos theta, and you remember these terms. Okay, then then it's easy for you. Okay, then it becomes very easy. Okay, now talking some important point about the work. Okay, now try to understand some very important point, about work. One of very important point is about the definition. Okay, definition. Now we are able to write down that we already write it and explain it. So next term is formula. Main formula is Fs cos theta, and third one is SI unit, its unit. Okay, firstly we discuss about its SI unit, then we discuss about the CGS unit. Okay, SI unit of work is, okay, we know that F cos theta is a kind of force. Okay, so its unit is, SI unit is, force is Newton, and S is displacement. Displacement is measured in meter. Displacement is a kind of length. Okay, so its SI unit is Newton meter, or simply you can say that joule. Okay, simply Newton meter is known as joule. Similarly, the second is CGS unit. CGS unit, if you talking about the CGS unit, then you know that in CGS system force is measured in dyne. Okay, and displacement is measured in, displacement kind of length. Okay, it measured in centimeter. Okay, so now combine dyne centimeter is known as erg. Okay, dyne centimeter is known as erg. Sometimes work is given in terms of erg, then you understand that, then if erg is given, then it means it is a unit of work. Okay, so fourth point, discuss about the relation. Okay, next term is relation. Okay, relation about work, and relation about joule, and erg. It means you are saying then what is the relation between 1 meter and centimeter. 1 meter is equal to 100 centimeter, and it means it is a relation. Okay, it means 1 meter is equal to, similarly 1 joule is equal to 10 raised to power 7 erg. Okay, this point is important for numerical way. Okay, numerical purpose, it is very important point. 1 joule is equal to 10 raised to power 7 erg. Okay, so this is the terms. Okay, now next term is define. We know that the SI unit is 1 joule. Okay, joule, so define 1 joule of work. Okay, define 1 joule of work. Okay, you define 1 joule of work, define it. Okay, now how you can define it? With the help of formula. We can define the terms with the help of formula. We know that work is equal to Fs cos theta. Okay, now how you can define it? Okay, let us take it an example. Suppose you applied a force 1 Newton. On a body, and body displays 1 meter. In the direction of force applied. It means in which direction you applied a force, body is also moving in the same side. Okay, body is also moving in the same direction. Okay, then work is said to be 1 joule. Okay, how? Put the value of force, magnitude of force is 1 Newton into magnitude, how much body displays? About 1 meter. And the angle between force and displacement, it means direction of the body is in the same direction. It means the if force and displacement are in the same direction, it means the angle between them is 0 degree. And we know that the value of 0 degree is 1. Okay, so it becomes 1 Newton meter, and we know that 1 Newton meter is said to be 1 Newton meter is said to be 1 joule. So you can define it. Work is said to be 1 joule when 1 Newton force is applied on a body and body displays 1 meter in the direction of force applied, that is the angle between force and displacement is 0 degree, then work is said to be 1 joule. Similarly, you can define 1 erg. Okay, you can define 1 erg also. In work erg, you change it in CJ systems. Okay, when work is said to be 1 erg when 1 dyne force is applied on a body and body cover 1 centimeter distance in the direction of force applied. Okay, in the direction of force applied, then it becomes 1 dyne centimeter, it means 1 erg. Okay, it means 1 erg. So in this way you define the following terms. Okay, now very important, discuss a very important term. Okay, which is work is a scalar quantity or work is a vector quantity? This is very important term. Okay, now tell me, is work is a scalar quantity or, very important point, work is a scalar quantity or a vector quantity? You saying that, sir, formula of work is Fs cos theta or simply Fs, then force is also a displacement, force is also a vector quantity and displacement is also a vector, so it definitely it is a vector quantity. But I am telling you work is a scalar quantity. Okay, scalar quantity, work is a scalar quantity. Many students are confused. Okay, how, sir, work is a scalar quantity? I do not understand. Okay, listen. Okay, okay, what is vector quantity? Okay, vector quantity are those quantity which has magnitude as well as directions, as well as, remember, not only direction or magnitude, as well as is follow some rules. Okay, algebraical additions is not getting the same result. Okay, actually there are some rules. Okay, and when we apply these rule in case of vector, then it fails. For example, if I taking about one of the example that is that current. Okay, current has, if you talking about the current, the symbol of current is I. Okay, then remember, when a current is passed through, okay, this is positive terminal, and you know that the direction of the current is from positive terminal to negative terminal. Okay, from positive terminal to negative terminal, but current is a scalar quantity, as although it has direction, but it is a scalar quantity. Actually what happened, every vector quantity follows some rules, and in this case this current and vector work fails. Okay, that's why not follow some of the rules of vectors. Higher classes you will learn about you will study about these rules. Okay, so remember this point, work is a scalar quantity. Okay, now discuss about the types of work. Now we study about, we will discuss about we discuss about the term types of work. How many types of work? Actually there are 3 types of work, and these types of work depends upon angle. Okay, according to the angle, if you're talking about the angle, then you can define the work in 3 parts. Number 1 is positive work. Okay, number 2 is negative work, and number 3 is zero work. Okay, positive work, negative work and zero work. Okay, as we know that the formula of work is Fs cos theta, and if I apply what is the visualization, then you can say that when you visualize it, then you can say that when work is said to be done when a force is applied in body, and body displays some displacement, and the theta is the angle between them. Okay, so let's start. When work is said to be positive work is said to be positive work when the angle is greater than or equal to 0 degree or less than 90 degree. It means the range of this is 0 degree if the angle between the force and displacement 0 degree, 1 degree, 2 degree, 3 degree, 4 degree, up to 89 degree, It means it is a acute angle. Okay, it means acute angle. If angle is acute angle, it means less than 90 degree. If the angle is less than 90 degree, then work is said to be positive work, because in this is first quadrant, this is second quadrant, third, and this is fourth quadrant. If the angle is in first quadrant, then value of cos is positive, and if the angle is second quadrant, if the angle is in second quadrant, this is the angle is second quadrant means greater than 90 degree and equal to or less than 180 degree, second quadrant, then the value of cos is negative. Okay, that's why it is considered to be, work is said to be positive. Okay, positive or acute angle, work is said to be positive when angle is acute angle, it means less than 90 degree. Remember, less than 90 degree, not equal to 90 degree. Okay, less than 90 degree but equal to or greater than 0 degree, then work is said to be positive. How? Then remember. Okay, then take it as example. Suppose there is a force F and body displaced in the direction of force applied, then angle is 0 degree. Then formula becomes, how much force is applied, put this value F. Now displacement is S and angle is cos theta means angle is 0 degree, so it becomes 0 degree, so it becomes Fs. So work becomes Fs. It is a product of force and displacement, so it is a special case as we discussed earlier. Okay, it is a kind of positive work. Okay, when the body is said to be negative work, I will take example. Okay, but now focus here. Negative work is said to be negative if theta is obtuse angle. Okay, obtuse angle, what the meaning of obtuse angle? Which is obtuse angle are those angle which is less than 180 degree, less than 180 degree or equal to or greater than 90 degree. Remember here, angle again I am not taking at angle is equal to 90 degree or okay, but I am taking here 180 degree is equal. Okay, so focus greater than 90 degree, or it means second quadrant. If your angle is second quadrant, okay, from positive x-axis. Okay, now it means its range is 91, 92, 93, 94, 95, 100, 150 up to 179, 180. So this is the range. If the angle lies in this range, then work is said to be negative work. What is the angle? Angle means the here angle means here angle is between the force and displacement. Now take an example. Suppose that, visualize it. Suppose we applied a force on a body F in this direction, and but body displaced in this direction, then angle between this becomes 180 degree, and we know that the cos 180 degree is -1. So work becomes F, how much force applied, S, displacement S, and cos, what is the angle between them, force and displacement is opposite to each other, so it is 180 degree, and it becomes F S -1. Work is said to be minus Fs. It equals to minus Fs. In this case there is no sign, it means by default it is positive. Okay, +1. Okay, so it is negative. Now there are third example is zero work. Actually there are lots of cases, okay, when you not applied a force on a body, then work is zero. Okay, when you there are lots of cases when you not applied a force on a body, then work is zero. If you applied force and body displaced, if you applied force but body not displaced, then again work is said to be zero, because when you put the value of, in first case when you not applied force, then work is zero. Okay, when you multiply it, okay, zero work has to come. Okay, you applied force but body not displaced, direct displacement. Okay, but body not displaced, it means displacement is zero. Put this value in this. And third one, which is very important, you applied a force and body displaced, okay, but the angle between force and the body is 90 degree. What it means? It means, visualize it with that you applied a force F on a body, but body displaced in this directions at 90 degree, then angle between it is 90 degree. Then we know that the cos 90, value of cos 90 is 0 degree. So the value of cos 90 is 0 degree. So it becomes, when you multiply it with, then it becomes 0. So put this value. Third case, we applied force on a body and body displaced, okay, but the angle between force and the body is 90 degree. Then we know that the value of the cos 90 degree is 0. When you multiply it, then it becomes 0. So in this case you can say that work is said to be 0. Okay, so in this way there are three cases. You can say that there are three types of work. First one is positive work, second one is negative work, and third one is zero work. When a body is said to be, okay, when a body is said to be positive work, negative work or zero work, okay, positive work, negative work or zero work. Body is said to be when you applied a force on a body and body displaced, okay, and body displaced 180 in the opposite direction, then angle is 180 degree, then work is minus Fs. Okay, when you applied a force on a body and body displaced in the same direction, then angle is 0 degree, then work becomes plus Fs. So it is positive work. But when you applied a force on a body and the body displaced at 90 degree, then angle is 90 degree and work is said to be 0. And work is said to be 0 because cos 90 degree is 0. cos 0 degree is 1 and cos 180 degree is minus 1. So when these terms multiply with this, then we get this formula. So there are three types of work. Okay, which one is most important? Actually each has same importance, but most of the question is asked from zero work. Okay, but many question is asked from zero work. Okay, suppose example. Okay, take some example of zero work. Okay, take some example of zero work. Suppose that suppose that this is sun. Okay, and we know that every sun okay, we know that every planet, suppose earth, okay, revolve around the sun. Okay, revolve around the sun. Then what happened? Then we know that suppose that in circular motion, then what happened? We know that every circulation, when body is in circular motion, then a force is responsible for it, which is known as centripetal force. We know about it. When a body is moving in circular motion, then a force is responsible for this circular motion, which is centripetal force. Okay, now talking about the accelerations. If you're talking about the centripetal acceleration, then it is always towards the center. But when you're talking about the tangential acceleration, there are two types of accelerations. One of them is radial acceleration, which is known as centripetal acceleration, and other is tangential acceleration. What do you understand by tangent? Tangent means a line which touches the circle at single point, which is known as tangential line or tangent. Okay, and the angle between radius and the tangent is 90 degree. Okay, so focus here. Okay, tangential acceleration is along the tangent. Definitely, when you suppose there is suppose that if there is no centripetal force. Okay, if centripetal force becomes 0, then what happens? Then at that point, when the centripetal force becomes 0, it moves along the straight line, along the tangent. The body starts to move along tangent. So acceleration of the body is along the direction of the body is direction of the acceleration is along the tangent. And we know that then if I am talking about the direction of velocity, then we know that the direction of velocity is same as in acceleration. Okay, and if I am talking about the direction of displacement, the direction of displacement same as along the velocity. It means indirectly the direction of the acceleration or direction of the displacement is along the tangent. Okay, ultimately the direction of the displacement of the displacement is along the tangent, because when you cut the centripetal force, then body starts to move along the tangent, starts to move. Then body wants to moving towards towards a straight line motions. Okay, but it does not pass because due to centripetal force it revolve around the circular path. So direction of the body is direction of the displacement is along the tangent line. So, and we know that the angle between tangent line and the radius is 90 degree. So along the radius we have a centripetal force. So direction of the centripetal force is along the radius and the direction of displacement along the tangent. So the angle becomes 90 degree. And we know that if angle becomes 90 degree, then what will happen? Then work is said to be, force is here, displacement is also, but angle is 90 degree. So it becomes 0. So it becomes 0 because cos 90, value of cos 90 is 0. So angle becomes 0. So in this way you are able to understand the zero work. So this is one of very important example. Okay, there is also a very important example when you tie up a stone with the strings and you revolve it, then there is also work is 0. Okay, then there is also work is 0. But if you're talking about, okay, suppose there is a another example. Suppose there is a pendulum, and this is pendulum, and pendulum revolves, oscillates around like this, okay, oscillates like this. Then what happened? Okay, now tell me the what amount of work has to be done. What is the amount of work? Okay, then you says that, sir, there is a tension is a kind of force, tension acting on the body, a kind of force F, and body, because body is moving from moving towards circular by a path which is a part of the circle. Actually the path of this pendulum is a part of the circle. Okay, when you draw the line, then you found that this is a part, this path is a part of the circle. It means this force is a kind of centripetal force. Okay, so you can say that the angle is, so when so body wants to, so the direction, but body is oscillate along this path, so directional displacement is again along the tangent, and it is a part of 90 degree. So angle between this is 90 degree. So work is again 0. Okay, so when a pendulum oscillates, then work is 0. When a body is rotating about, when a planet is rotating about the sun, then work is 0. Okay, I hope you understand these terms. Okay, now take an example which is very important example, and I hope with the help of this example you are able, okay, with the help of this example you are able to understand types of work. Okay, so let's start. Suppose that, take three case 1, there are three case 1, case 2 and case 3. Okay, there are three case 1, and there is a porter. Okay, there is a porter which wants to carry a luggage on his head. Then he moves along the platform, and finally when he reached the destination, then take off the luggage from his head and put it on the ground. Then there are three cases. Okay, there are porter. In first case, porter carry some luggage on his head. Then he moves along the platform, horizontal platform, and then finally he reached the destination. It means you can say that he reached at the train or at the exit point, and then he take away this luggage from his head and put it on the, then he put it on the ground. Okay, there are three cases. Okay, in these three cases, one of them is positive work, one of them is negative work, and one of them is zero work. You have now you calculate, now you identify which of them is positive, negative, or zero. Okay, try to solve it. Okay, so let's start it. Okay, now in first case, what happened in first case? Okay, suppose that this is the luggage and the porter wants to carry it on his head. Then he lift the luggage. Okay, then when he lift the luggage, then he applies some force in upward direction. Okay, then he applies some force in upward direction. Okay, it means direction of the force is in upward directions. You applied force in upward directions and direction of force. Okay, and body is also moving in upward direction. It means it means direction of displacement is also in upward direction. So what kind of work is it? It is a positive work because its angle is 0 degree. So work is equal, we know that work is equal to Fs cos theta, and cos 0 degree is 1, so it becomes Fs. So it is a positive work. This is the example of positive work done by porter. So work done by the porter in this case is positive, but when he carry this luggage on his head and walk along the platform, then how much work is did? Okay, then try to understand this. Okay, suppose this is the box, this is the luggage, and porter carry it on his head and walk around this. Then you know that the body is moving along the platform. So its direction is S. It's easy. But what about the force? What is the direction of force applied by the porter? Okay, listen. Actually, what happened? The luggage has some weights. So the weight is luggage has some weight, and the direction of the weight is always along the center of the earth. So it's downward direction. It means this luggage exerted a force on porter. This means this weight of the luggage is applied on the porter. So according to the Newton's third law, what happened if this luggage applied a force on porter? Then what happened? Then porter also applied same force in opposite direction. Same force is opposite direction. It means porter applied a force on luggage which is opposite to the weight of the body. So the angle between force and displacement is 90 degree. So you can say that the angle is 90 degree, and we know that if the angle is 90 degree, then work is said to be Fs cos 90 degree, then work is said to be 0. It means this is an example of 0. Okay, come on the last case. When the porter put it on the ground, then what happened? Focus here. When suppose that when it is on his head, okay, and he wants to put it on the ground, then what happened? When it put on the ground, then what happened? Actually force is applied by the porter is again here in upward direction. Okay, you try to put a book or any object on the ground, then you found that you again is apply a force in upward direction. Okay, when you again, but body is moving in downward direction. It means direction of the body is in downward direction, but the force applied by the porter is in upward direction. So the angle becomes 180 degree, because angle is 180 degree. So work is equal to Fs cos 180 degree, and we know that the angle cos 180 degrees is -1, so it becomes minus Fs. So this is an example of negative work. Okay, this is an example of negative work. So okay, if you have a heavy box and you applied a force on it and body is not displaced, then work is 0. But if you have a light box and you applied a force and body displaced in the same direction, then work is positive. Okay, then work is positive. Okay, remember one thing, you know about the friction. Okay, you know about friction. Okay, listen, when you suppose that there is a box, okay, and box moves in this directions, okay, box moving in this direction, it means displacement of the body is in this direction, but frictional force is always acting acting along the contact of surfaces. which is always in opposite direction, which is always in opposite direction. Frictional force is always opposite direction. So how much work is done by friction? How much work is done by the friction is Fs, and the angle is 180 degree. 180 degree. So it becomes minus Fs. It means work done by the friction is negative. Work done by the friction is negative. But when you push it, it means you applied a force F1. Okay, suppose F1. You applied a force F1 and body displaced in the same direction. Then how much work is done by you? By you. Then work done by you, by the person, is positive work, because F1s, because the body in the same direction, so angle is 0 degree, so it is positive work. Okay, but work done by the friction is negative work. Work done by the friction is negative work. I hope that you understand this this way, the types of work. Okay.